My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 427. In this lecture, I will continue my discussion on stacking models. So, it's very important that you need to train your meta classifier on the outputs or the predictions of your base learners. Just see, this is my meta classifier, isn't it? You need to train this meta classifier on the outputs or predictions. These are the outputs or predictions of your base learner, or I can say classification models. This is very important. Having understood this basic concept, let's see some simple code. Example 1, simple stacked classification. Thankfully, ML extend has written some of the code for stacking classifiers, keeping in mind that it has to be compatible with sklearn. Let's take simple example here. Here I am importing. You need to import ML extend which is very simple. How can I do it? Just go to the documentation of ML extend and you can see how to install it. Now let's just see how to install it. Just see here you have installation. Just see here, this one. Just see here, this one is installation. Yes, this one installation. Here just click this one. What you have to do here, I go to the just installation, open in new tab. Just I'm clicking in open new tab. If I go to the new tab, it's as simple as this. If you using Python 3, just if it is just what is the pip I can say pip install ML extend, isn't it? If using Python 3, just say pip 3. In the case of Python 3, I must say pip 3 install ML extend. If you use Python 2 version or 2.x version, just say pip install ML extend. That's why I love Python. Installing any new package literally like one line command. So once your installation, once you installed ML extend, all we can do is basically importing this line. What is this line? From ML extend dot classifier import stacking classifier. ML extend has other classifiers also. We are importing stacking classifier. Here I am creating a bunch of base classifiers. I am creating, what is this, CLF1 as KNN. What is my CLF1? CLF1 is, I can say it is a KNN. Just you can check it out. Just see this one. Yes, yes, let me say like this. Yes, this is CLF1, K nearest neighborhood classifier, isn't it? CLF1 is actually, what is my CLF1? That is KNN. CLF2, CLF1 as a KNN with one neighbor. How many neighbors? I have only one neighbor. My second base classifier is a random forest classifier. That is I can say that second one. CLF1 is, what is my CLF1 is h1 of x. I can say this CLF1 as h1 of x, CLF2 as h2 of x, CLF3, what is my CLF3? Gaussian naive. Let it be h3 of x, and I am just using default here. My fourth model means h4 of x. My fourth model is logistic regression, h4 of x. Just see, this is logistic regression. Just you can understand this. Just see, logistic regression, LR I can say, isn't it? Yes, I am just using default parameters in the case of logistic regression. Once I have all of them, I am creating stacking stacking classifier. I'm calling stacking classifier as SLF. SLF is my stacking classifier. Here I'm giving the list of all the classifiers I have. Here I'm saying I want to build my stacking classifier using my CLF1, CLF2, CLF3, and which are these three classifiers as the base classifiers. My CLF1, that is k nearest neighbor with neighbor 1, CLF2, that is random forest, CLF3, that is Gaussian naive base, which are these three classifiers as the base classifiers. And what is the meta classifier itself? I want to use logistic regression. I want to use which one? Logistic regression as my meta classifier. Just see, meta classifier equal to LR, that is logistic regression, isn't it? So your h1 of x is your CLF1, h1 of x equal to CLF1, and h2 of x h1 of x is CLF1, h2 of x is CLF2, h3 of x is CLF3. CLF1 means KNN, CLF2 means random forest, CLF3 means Gaussian naive base. These are, I can say, these all are my base learners, and my final meta learner is logistic regression, that is h dash of x, isn't it? Just check, this one is h dash of x, isn't it? H dash of x is logistic regression. Now it's very simple to train. I defined how my stacking classifier work. If once I define, it's very simple, isn't it? Just say this one. I can say, suppose if I wanted to do threefold cross validation, I just write this for loop, isn't it? What is this for loop? Just check this particular for loop. This is the for loop. This for loop, in each of this for loop, I am training basically KNN. Just see which one am I training? I am training KNN, isn't it? I am training basically KNN perfectly using cross validation. I am training KNN random forest naive base, and I am also training stacking classifier. By combining KNN random forest naive base, by combining three, which three? KNN random forest naive base. Once you do this, I am doing here threefold cross validation, isn't it? The threefold cross validation, as you can see here, I'm trying to compute cross validation score. What is my cross validation score? I am trying to compute my cross validation score. What it is? I am trying to compute cross validation score with CV equal to 3. That is important here. What is my cross validation value? Just see this CV equal to 3, and I am using training data here, capital X comma Y. This is my training data. Just see, this is capital X comma Y is training data. The stacking classifier internally, because I have defined it clearly, stacking classifier has to use the outputs of CLF1, CLF2, CLF3, our SCLF equal to, what is my SCLF equal to, that is stacking classifier. It internally takes care of all of the complexity in using outputs of h1 of x, h2 of x, and h1 of x and h2 of x and h3 of x. It automatically uses the output of them to train our h dash of x. It does internally for you, isn't it? So as you can see, on a very simple data set, I think the data set used here is iris data set, very simple data set. On iris data set itself, when we do threefold cross validation, your simple KNN with k equal to 1. Just see, your simple KNN with k equal to 1 gives accuracy of 91%, isn't it? Your random forest gives an accuracy, your random forest is giving an accuracy of what? Just see, this KNN and random forest is also giving accuracy of 91%. Your naive base, what is the naive base? What it says, your naive base, just check it out here, what it says. Yes, just let me show this one. KNN 0.91, random forest 0.91, naive base 0.91, but your stacking classifier here wherein you take all of them and stacking it using logistic regression. Your stacking classifier here, logistic regression gives a slightly higher accuracy of, what is this accuracy, 0. Gives slightly higher accuracy of 0.95. This is to show that even on a very simple data set like iris data set, the accuracy used, iris data set, load what is the function iris data set, we have seen load underscore iris, and very simple things like iris data set is also very simple data set stacking classifier has a higher accuracy, 0.95 over the base learners. It's very simple idea. Now of course you will get visualization. This page is very good. Just see, just check, you can see the different graphs, KNN, random forest, nairbase, and stacking classifier visualizations. This is there is a lot of code here. This is the simplest code possible. Of course there is a more code. Instead of using class label itself, if you want to use probabilities as meta feature, so instead of using class labels of each of them, for example, if you have models h1 of x, h2 of x, h3 of x as a base models, given in a query xq, it says whether the class label is 1 or whether the class label is 1 or 0, right? Isn't it? Instead of using these values, if we want to use probability values, that's also very simple. Just literally one line code change. The code change here is, what is that code change? The code change has here is, when you are defining stacking classifier, you say CLF1, CLF2 and CLF3 are my CLF1, CLF2 and CLF3 are my base classifiers, and you have to say use underscore prob equal to true. Just say use underscore prob equal to true. What it means, it says use probabilities. When you say use probabilities meta classifier as logistic regression, it uses the probabilities instead of absolute values. Very simple thing. Of course you can use stacked classification, and grid search. There is a lot of source code here. You have to navigate multiple cases. So this library is very well implemented. I have used myself a couple of times, but remember MLextend works very well with scikit-learn. Remember, stacking has very key points. Those key points I will discuss in my next lecture, that is in lecture number 428. Thank you very much.